By the end of this lesson, the students will be able to define strong and weak bases, define base dissociation constant Kb, calculate Kb, the concentration of OH- and the pH of a base. Compare the strength of bases using Kb and pKb values. Sodium hydroxide is a base. Click the Add button to dissolve sodium hydroxide in water. Is sodium hydroxide a weak or a strong base? Discuss and click the Next button. Answer: sodium hydroxide is a strong base as it ionizes completely when dissolved in water to produce a high concentration of OH- ions. Other strong bases are potassium hydroxide and barium hydroxide. We can calculate the pH of the aqueous solution of a strong base if we know its concentration. Click on pOH and pH in the table to view their expressions. Select sodium hydroxide from the drop-down menu. Key in the correct values for hydroxide ion concentration. Click the Clear button and select barium hydroxide from the drop-down menu. Repeat the exercise assuming that it is completely soluble in water. Ammonia is also a base. Click the Add button to dissolve ammonia in water. Is ammonia a strong or weak base? Click the Zoom button to have clear view of the molecules. Discuss and click the Next button. Answer: ammonia is a weak base as it is only partially ionized in water and produces a low concentration of OH- ions. Some other examples of weak bases are ethylamine and beryllium hydroxide. Summary: a strong base is a base that ionizes completely in water to produce a high concentration of OH- ions. A weak base is a base that does not ionize completely in water and produces a low concentration of OH- ions. Consider the case of a weak base B with an initial concentration of C-mole per decimeter cube and a dissociation constant Kb. Click the 2 button to obtain the concentrations at equilibrium. Now, click the 3 button to view the expression for Kb. For most weak bases, alpha is very small. Hence, 1 minus alpha is approximately equal to 1. Click the 4 button to get the final expression for alpha. What happens to the degree of dissociation of a base when the solution is diluted? Answer: the degree of dissociation of a base increases with increased dilution, that is, lower concentration. Alpha is inversely proportional to root of C. Summary: the degree of dissociation of a weak base increases as the concentration of the solution decreases. The ionization of a weak base in water is a reversible reaction. The position of equilibrium varies from base to base. We can get a measure of the position of equilibrium by writing an equilibrium constant for the reaction between base B and H2O. Click Start button. Kb is called the base dissociation constant. It is a constant value at a fixed temperature. Ammonia is a weak base with a Kb value of 1.8 times 10 to the power of -5 mole per cubic decimeter at 25 degrees Celsius. Calculate the pH of the solution formed when 0.2 mole of ammonia is dissolved in water to make up to 1 mole per cubic decimeter of solution. To start, click the equation button. We can calculate the concentration of OH- of the solution in two ways. Click the Method 1 button. Let X be the number of moles of ammonia that ionize. Click the 2 button to get the equilibrium concentrations. Click the 3 button to get the expression for Kb. Drag and drop the correct values into each of the empty boxes to get the final value of Kb. Click the Kb button. The concentration of OH- ion is equal to X. Click X button. We can also calculate the concentration of OH- ion of the solution using an alternative method. Now, click the Method 2 button. Click the Kb button. Now, click the concentration of OH- ion button to get its value. We can now calculate the pOH and hence the pH of the solution. Click the pOH button. Click the pH button. Select Example 2 from the drop-down menu. We can find the base dissociation constant using the relationship the concentration of OH- ion is equal to the square root of Kb times C. Click the Start button. The value of Kb is obtained as shown. Summary. Kb is called the base dissociation constant. We can calculate the pH of an aqueous solution of a base by first finding its concentration of OH- ion and then using the formula pH plus pOH is equal to 14. Different bases have different values of Kb. Click the Sort button to arrange the bases in order of increasing base strength. The pKb values of the 4 bases are shown. Drag and drop the correct values into the empty boxes in the table. Summary. The larger the Kb, the stronger and more fully ionized the base. The stronger the base, the smaller its pKb value.